This video will demonstrate how to use test points to solve a rational inequality. We want to solve the inequality, the quantity 12 minus 4x divided by the quantity x squared is greater than or equal to 0. To solve using test points, we first find the boundary numbers, which are solutions of the associated equation and also the values that make the function undefined. When we set 12 minus 4x divided by the expression x squared equal to 0, we can multiply each side by x squared to get 12 minus 4x equals 0, or 12 equals 4x, or 3 is equal to x, is one of our boundary numbers. Then the function is undefined where the denominator is equal to 0, or where x squared is equal to 0, and that is at x equals 0. So we can place these boundary numbers of 0 and 3 on the number line. I'm going to place a mark at 0 and place a mark at 3. And notice that this subdivides the number line into 3 regions. That is, the numbers to the left of 0, which corresponds to the interval negative infinity to 0. The numbers between 0 and 3, the interval 0 to 3. And then the numbers to the right of 3, which is the interval 3 to infinity. A test value in each of those regions is -1 in region A, in region B, something between 0 and 3, so we can use 1. In region C, something larger than 3, so we'll use 4. Now we place those values into the original inequality to see if we get a true or false statement. Replacing x with a -1 gives us the expression 12 minus 4 times -1, all divided by -1 squared. Is that greater than or equal to 0? When we simplify, we get 12 plus 4, or 16, divided by 1, which is 16, which is greater than or equal to 0. In region B, we replace x with 1 to get 12 minus 4 times 1, divided by 1 squared. Is that greater than or equal to 0? When we simplify, 12 minus 4 is 8, divided by 1 squared is 1, so that's 8, which is greater than or equal to 0. In the third interval, we test 4, so 12 minus 4 times 4, divided by 4 squared. Is that greater than or equal to 0? The numerator is 12 minus 16, or -4, divided by 16. Is that greater than or equal to 0? No, a negative number is not greater than or equal to 0, so this is false. So using the test point method, I know that regions A and B are where solutions lie. I'm going to shade region A, which is everything to the left of 0. And then region B is between 0 and 3. And now I need to be careful about what happens at these endpoints. Remember that the number that makes the function undefined can never be included in the solution set. So the 0 value has to be excluded from my solution set because it makes the function undefined. So I'm going to have a parentheses pointing to the left of 0 and then a parentheses pointing to the right of 0 on the number line. Can I include the 3? The 3 came from where the equation or expression was equal to 0, and I am permitted to find where the expression is greater than or equal to 0, so 3 can be included in my solution set. So I put a bracket at 3. Therefore, my solution set is negative infinity to 0, parentheses, union, parentheses 0 to 3 with a bracket.